Alright, so here we are with 8.3, adding and subtracting rational expressions. We want to add and subtract rational expressions, and we want to simplify some complex fractions. You might want to be careful with this one. Make sure that you do know how to factor, because that's going to be very key, especially when we have to, say, find new or say least common denominators. So let's start off with something easy, and that would be dealing with the, say, least common, finding or adding, subtracting them when they have the same denominator. So that one should be very simple. Keep in mind you may still be asked to find the points of where they're not defined. Okay, so here's our first example. 3x minus 4 over x plus 3 plus 2x plus 5 over x plus 3. Since they have the same denominator, remember when you add two rational expressions or two fractions, you do nothing with the denominator. You're just trying to make sure they had the same denominator, then you add or subtract the numerators. So here I'm going to say 3x plus 2x is 5x, negative 4 plus 5, notice how I'm saying that, negative 4 plus 5 is going to be positive 1. All of that over x plus 3, and technically I'm done, although I will make note that this function cannot be equal to 3, or it can be any x but 3. It's undefined at, negative 3. That should be a negative 3 because that's where that would make the denominator equal to 0, and actually the denominator of one of the original functions. So that would be the first example. The next example is 2x minus 1 over x squared plus 2 minus 4x plus 4 over x squared plus 2. Again, since they're the same, we're going to say we're going to subtract here. You got to remember you need to distribute that minus sign to both the 4x and the positive 4. So in reality, this is 2x minus 1 minus 4x minus 4. I'm going to put them all together over the x squared plus 2. So I can do it like that where you see them all together. And then I'm saying 2x minus 4x is negative 2x. And negative 1 minus 4 is negative 5. Now because this one is a square on the bottom here, that means that it would be defined at any point. So there are no points of undefined. Okay, so on page 584 they're going to talk about finding the LCM. I ended up still writing it here. You're going to factor each polynomial and write repeated factors as powers. List the different factors. If there are any common factors, use the highest power of each. Now we're doing this so that can help us find the least common denominator for a fraction later on. Okay, but this is just an example. Okay, so we want to find the LCM of 2x to the 5th, y to the 4th, and 3x to the 5th, y cubed. Actually, this should be 2x to the 3rd power, I believe. And so, yeah. 2x to the 3rd power, sorry, and y to the 4th, and 3x to the 5th, y to the 3rd. So if we separate these, we look at this, 2 and 3, those are just prime numbers, so I can just put those two together. So I'm going to put 2 and 3, and then I look at the x's. I see that both of them have x's. I take the highest one of those two, so I'll go with x to the 5th. I look at the y's and I see that there's two different y's on each one, and I'm going to go with the one with the highest power, y to the 4th. This right here represents the least common multiple, and so I can say 2 times 3 is 6, x to the 5th, y to the 4th. That would be the least common multiple of 2x to the 3rd, y to the 4th, and 3x to the 5th, y cubed. Okay, here's another example. This one's with a polynomial equation that you're more used to, or for expression, x squared plus 3x minus 4, x squared minus 3x plus 2. We go ahead and factor this first, so let's think. Plus minus is a plus minus, so I'm going to put x plus and minus. Factors of 4 that add or actually subtract to give me a 3 would be 4 and 1, and it should be 4 minus 1, because 4 minus 1 is positive 3. On the other one, minus plus is minus minus. And then factors of 2 are 1 and 2. And then I can see here that I've got the least common multiple. Let's look at this. We got the x plus 4, so we're going to put that x plus 4. And then on the next one, we're going to say the x minus 2. And then I can see that the x minus 1 repeats. Since it's in both of them, I only need to write it once. And that's my least common multiple, right there. X plus 4 times x minus 2 times x minus 1. If you want to actually multiply that out, great, but you don't necessarily have to. Okay, so now let's add or subtract when the denominators are not the same. And remember, to add or subtract fractions, you have to find the least common denominator. Okay, so if you look at this example, x minus 1 over x squared plus 3x plus 2 plus x over x plus 1, you can tell that they're not the same. So let's factor the x squared plus 3x plus 2. That's plus plus. And so it would be 2 and 1. And then if you look over in this one's already factored, x plus 1. But if you look at that fraction, this fraction has an x plus 1, which is already in the other denominator. So what is it missing? Well, it is missing an x plus 2. Now if you put an x plus 2 here, these will match. But now you need, if you want to add an x plus 2 to the bottom, you got to be fair and add an x plus 2 to the top and multiply it out. So that gives me x minus 1 plus, and I'm going to multiply this as I'm writing it out, x times x is x squared, x times 2 is 2x. All of that over the x plus 1 and x times x plus 2. Combine your like terms, you'll have x squared plus 3x minus 1 over the x plus 1 x plus 2, which is x squared plus 3x plus 2. It really shouldn't be hard to multiply those two. This is, by the way, undefined at -1 and -2. Because if you think about it, this x plus 1, x plus 2 was this right here factored. So if you've already got that, it shouldn't be that hard to multiply that and get back to that. Just use a little common sense and that should make that easy. Let's do another example of that. X over x plus 3 plus -18 over x squared minus 9. There's nothing I can do with the x plus 3, so I'm going to factor the x squared minus 9. So you're looking for ones that can be factored, and generally the ones with squares are the ones that can be factored. And again, this is a difference of two squares, so that's x plus 3, x minus 3. And then since this first one is missing an x minus 3, I need to multiply both top and bottom by x minus 3 over -18 x plus 3 x minus 3. Now when you multiply that out, you got x squared minus 3x, and then you still got plus the -18, which is just minus 18 over the x plus 2 x minus 3. There are no like terms combined, so essentially that's your answer. Now if you want to multiply again the x plus 3 x minus 3 and put that as x squared minus 9, more power to you. It might be what you might see on the answer choices on the test, so you might want to make sure you keep that in mind. And again, if you notice here, the easy part is if you factor it out, we generally try to do this where one of the two terms or one of the two expressions is missing, and that's the one you multiply to the other fraction, both top and bottom. Okay, fraction or subtraction is no different. So let's look at this example, 2x squared minus 16 over x squared minus 4 minus x plus 4 over x plus 2. Again, factor the x squared minus 4, it's x plus 2, x minus 2. And then from there, you've got I need to multiply both top and bottom on the second one by x minus 2. Keep in mind there's that minus there. Okay, now with the numerators, I actually do need to multiply them out. So I have 2x squared minus 16 minus, I'm going to put this in parentheses, and I'm going to multiply these up here on top and write my answers as I'm doing it. X times x is x squared. X times -2 is -2x. 4 times x is 4x. 4 minus 2 is 2x. So again, notice what I did there was I knew I was going to combine those two, the 4 and the minus 2, and just put an x. And then 4 times -2 is -8. Distribute your negative, and you're going to have -x squared minus 2x plus 8 And so I'm saying 2x squared minus x squared is x squared. 2x minus 1, or 2 minus 1 is 1. Minus 2x and negative 16 plus 8 is negative 8. All of that is over x squared minus 4, or x plus 2 times x minus 2. Okay. Now, keep in mind though that you could have simplified that further, and you can see here that the x squared minus 2x minus 8 is minus minus is a plus minus. So I went ahead and put it here plus minus, and it was 2 and 4, so that my x plus 2's could cancel out and leave me with an x minus 4 over x minus 2. I'm not exactly sure how I would put that into a problem. It's something you need to double check and keep thinking about. Maybe I split that into 2 problems for y'all to make sure that y'all fully factor that out. Let's look at a complex fraction here, and you can see with this complex fraction we've got the x plus 1 over x squared minus 1, which is that over x minus 1. This to me looks confusing. You need to keep in mind that what this is doing is like saying x plus 1 over x squared minus 1, which is x plus 1 x minus 1. So I factored this right here, divided by x over x minus 1. Now let's switch that. Okay, so remember, when we divide by a fraction, we multiply by its reciprocal, and then start kind of cross dividing. The x plus 1's cancel each other out, the x minus 1's cancel each other out. So you're always looking for, from top to bottom, what things could cancel out. Nothing is left on top, so I've got a 1 on top, and all that's left is an x on the bottom. So that's my final answer, 1 over x. Okay, so let's look at this example, and let's see if I can shorten this up a little bit. What's going to happen here is this. It's going to end up that these two will actually multiply to be on the bottom. These two will multiply and be on top. So I would go ahead and make that switch as I'm writing it. So here I've got 20 over x minus 1 times. I'm going to factor the 3x. I can factor that to 3 over x minus 3 over 6. Actually, I'm sorry, that's 3 over x minus 1 over 6. Well, the x minus 1's cancel each other out. 20 times 3 is 60 over 6, which simplifies to 10, and I'm done. Okay, so you can kind of do that, and just keep in mind factoring. You never know what could happen with this as you work in it, but again, that's something, it's one of those, if you take your time, do your steps, it should make it a lot easier. That's 8.3, and if there are any questions, feel free to let me know or send me a little thing through Edmodo, because again, I will be leaving for state soon. So go ahead and do that. Try to work on your assignments, and good luck.